All right, let's take a look at this and let's do the same thing we did before. Before we were adding and subtracting or combining, now we're going to start with multiplying. I want to multiply these, and then when I'm done multiplying these, I want to change each fraction or mixed number to a decimal, and then see if we can come up with some kind of pattern that we see. All right, so here we go. 7 over 1. Remember, if we're doing these as fractions, we're going to make everything look like a fraction. So this is 10 times 3 is 30, plus 1 is 31 tenths. Okay? Now we're going to multiply across. 7 times 31, because we can't reduce. 7 times 31 is 217. 1 times 10 is 10. So that's what we have. Now if I change these to decimals, let's take a look at what we have. If I change these to decimals, we have 7. If I want to write, I'll just write 7, in fact. 3 and 1/10 is 3.1. And this is 217 over 10. Let's write this as a mixed number. So 10 into 217, that's 2. The remainder of 1. 10 into 17 is once, and there's 7 left over. So it's 21 and 7/10, which, if I write that as a decimal, is 21.7. So just take a look at that and see if you can come up with some kind of pattern. And then we'll take a look at this, and then we'll write a decimal for this and see if you can compare the decimals and see anything really cool going on. All right, so again, we're going to multiply this. So that's 100 times 5 is 500, plus 1 is 501 over 100, times 3 over 100. That will give us, I'm going to write it this way I have more room underneath. This is 1503 over 10,000. So let's write these as decimals. 501 over 100, or 5 and 1/100ths, is 5.01, right? Tens, hundredths. 5 and 1/100ths. 3 hundredths is 0.03. This answer is 1503 over 10,000s. 10 hundredths, 10 hundred thousandths, 10,000 is 4 zeros, right? So 0.1503, right? 10 hundredths, thousandths, 10,000ths. So that's how you write that. Do you see any kind of pattern with this? Just take a look. Take a look for a second. Do you see a pattern? All right, I'm going to show you a pattern. Right now, I was trying to line up the decimals, but I'm not sure we have to. Let's take a look. Right now, there are no decimal places in this number. We can add some, but there are none. Right here, there's 1 decimal place, right? After the decimal, there's 1 decimal place. In my answer, there's 1 decimal place. Here, there's 2 decimal places. 1, 2. Here, there's 2 decimal places. But here, there's 4 decimal places. Do you see any kind of pattern now? 0 plus 1 is 1. 2 plus 2 is 4. So here's what happened. What happened was we just multiplied the numbers regularly. You do not have to line up the decimals. We're going to talk about why not. You do not have to line up the decimals, but once you multiply regularly, 3 times 1 is 3, 3 times 5, 3 times 0 is 0, 3 times 5 is 15. You get this answer, and you just count the number of decimal places. 2 here, 2 here, so there'll be 4 in my answer. That's all I do. Let's talk about why we don't have to line up the decimals. It's only in addition and subtraction that you need to have like terms. Even with our expressions, we need the like terms to add them. Well, we had like terms in addition and subtraction because when we lined up the decimal, we added the hundreds place with the hundreds place, the tens place with the tens place. We don't have to do that in multiplication. We just have to worry about the number of decimals. So let's do some problems and we'll show you what I mean. Oh, wait, there's one more. Let me do one more just to make sure. You can tell me what you think. Here we go. I'll tell you what. Let's do this. Instead of doing this next one like these, let's change the pace a little bit. See what you can do with it. I'm going to take 15 and 3/10 and write it right away as a decimal. 15 and 3/10. I'm going to take 1/100ths and write that as a decimal. Again, I'm lining up the decimals, but I really don't have to. Let's talk about what we think we should do. There's 1 decimal place here. There's 2 decimal places here. That means there should be 3 in our answer. Okay? So watch. 1 times 3 is 3. 1 times 5 is 5. 1 times 1 is 1. When I multiply by 0, that's not going to help me. There are just 3 decimal places in our answer. I'm thinking that will be the answer. I'm going to now do it as a fraction because that's what you know. Okay? So let's take a look. So I just went backwards to kind of see that we understood what we were doing. So 15 3/10, let's do it as a fraction, times 1 over 100. Look what my answer is, 10 hundredths thousandths. So I'm thinking my answer should be 153 over 1,000 if we did this right. You ready? 10 times 15 is 150, plus 3 is 153 over 10, times 1 over 100 is 153. Oh yeah, awesome. So now we know how to do it. So let's just practice by multiplying and using this rule. Okay. 3.08. 3.08 times 0.4. If you like that 0, okay. When I write it down, I'm going to go 3.08 times, I'm just going to use the 0.4. I know that's 0 ones, okay? Here we go. I'm going to make that times a little smaller. It's kind of overwhelming for me. Okay, here's what I'm going to do. I'm going to count the number of decimal places. So there are 2 here. After the decimal, 1, 2. To the right of the decimal. There's 1 here. So there should be 3 in my answer. So here we go. 4 times 8 is 32. Carry the 3. 4 times 0 is 0, plus 3 is 3. 4 times 3 is 12. So I'm not bringing the decimal down. I don't even have to line up my decimal. I just know they're going to be 3 places in. So here we go. We count 3 places. 1, 2, 3. There's my answer. 1.232. So 1 and 232 thousandths is the answer. Cool, right? That's really nice and simple. Let's try number 2. And again, if I have signed decimals, take care of the signs first. So I have negative 0.207 times 5. So I'm going to write it here, 0.207 times 5. All right, here's the deal. The deal is that I have a negative times a positive, so I know my answer is negative right from the get-go. Take care of that. 5 times 7 is 35. Carry the 3. 5 times 0 is 0, plus 3 is 3. 5 times 2 is 10. I count the number of places. There are 3 here. Should have did that first, I'm sorry. There are 0 here. 3 plus 0 is 3. So I count in 3. 1, 2, 3, and here's my answer. Negative 1 and 35 thousandths. Okay? You might want to get used to just doing and counting decimal places first so you don't forget to do that. Okay? Here we go. That was number 2. I'm going to do number 3 with you, and you can try 4 and 5. Okay. Try not to leave anything on a board that could look like a negative. Okay, 3. I'm going to show you something really cool about this. Negative 0.03 squared. Okay, this takes a lot of things into account. Remember the exponent? The exponent works onto whatever's to its immediate left. So if this falls, it falls on the entire parentheses. So that means you're squaring the entire parentheses. So when negative times a negative, it means your answer is going to be positive when we're done. Okay? Now I'm going to do 0.03 times 0.03. 0.03 times 0.03. You ready? 3 times 3 is 9. 3 times 0 is 0. I don't have to do everything else with that 0 because I know this. I know if this is 2 places in and this is 2 places in, my answer's got to be 4 places in. How do I get my 4 places? All I did was multiply to 3 because the zeros won't help me. They'll just be 0 when I multiply. I go 1, 2, 3, 4. I'm going to have to add 2 zeros. So it's 0.0009. 9 ten-thousandths. Okay, is my answer. Positive. All right, you can try 4 and 5, and then we'll check your answers. All right, let's take a look at what you did. Let's look at this problem. Is this problem really any different from the one we just did? Well, If you remember the one we just did, had parentheses here. Remember, the exponent only works on what's to its immediate left. So if this exponent falls, it's only falling on the decimal. So really, this is negative on the outside, 0.03 times 0.03 or 0.03. Okay, here's the deal. The deal is that the negative is not being squared. That tells me my answer is going to be, negative. Almost said positive, negative, because the negative is not being squared. So now let's multiply this. All right, so this is 2 places, this is 2 places, so it needs to be 4 places in my answer. Again, if I multiply by 0, nothing's going to happen. So 3 times 3 is 9, 3 times 0 is 0, okay, but now I need 4 places. So 1, 2, 3, 4. Should have got the same answer, just a different sign. So it's negative 0.0009 or negative 9/10,000ths, okay? Let's take a look at this. 0.009, that's negative, times 0.6. They're both negative, so my answer is going to be positive. I'm just leaving out the 0 in the front. Okay, watch. 6 times 9 is 54. 6 times 0 is 0. 6 times 0 is 0. But this is in 3 places. This is in 1 place. My answer's got to be in 4 places. Oh, I see the 4 places already. So 0.0054 or 54/10,000ths. Okay, and that's all there is to it. Just count the number of places and multiply like you always would. All right? So let's revisit something we did in Mod 1. In Mod 1, we multiplied by powers of 10, you might remember. Okay, I'm just going to revisit that with the first 3 examples and then talk about the next 3 examples. Number 1 is 7 times 10. Oh, using a dot, sorry. Using a dot. Number 2 is 7 times 100. And number 3 is 7 times 1,000. Remember what we did when we did this in Mod 1? 7 times 10, all we had to do was 7 times 1 and add the same zeros. 7 times 1 is 7, 1 0. 7 times 1 is 7, 2 zeros. 7 times 1 is 7, 3 zeros. That's what we did, and that was fun, and that was easy, and that's all we said. I so much wanted to say something else, but I couldn't because we didn't learn decimals yet. So I want to take a look at this next problem because I really want to show you what's truly going on. Let's do 0.7 times 10. Again, the dot, sorry. Okay, I just don't like dots with dots. They make me nervous. Okay, at any rate, 0.7 times 10, watch this. I'm going to do this. This is 1 place. This is 0 places, so we need to be in 1 place. You ready? 0 times 7 is 0. 1 times 7 is 7. But we need to be in 1 place. So here's 1 place in. And that's the answer there is 7. Okay? So the answer here is 7. Let's do the next problem. 0.7 times, I'm a slow learner, 100. If we do this, we are going to get, watch, 0.7 times 100. We're in once, we're in nonce. We got to be in once when we add that up. So 0 times 7 is 0, 0 times 7 is 0, 1 times 7 is 7, but I got to be in only once, so right here, and we have 7D, okay, 7D. Okay. Now our next problem is 0.7 times 1, oh, I am a slow learner, times 1,000, okay, so 0.7 times 1,000. And now, look, we're in once, we're in nonce, so we got to be in once. Ready? 0 times 7 is 0, 0 times 7 is 0, 0 times 7 is 0, 1 times 7 is 7, but we got to be in once. So that's 700. That's 700. All right, I'm going to take this off the board, and we're going to talk about a little pattern going on. What really happened to the decimal point? Well, the decimal point here moved over 1 to the right. 1, 0. 1 to the right to make that 7. The decimal point here moved over 1, 2 to the right to make that 70. Okay? The decimal point here moved over 3 to the right. 1, 2, 3. Okay? To make that 700. So all that multiplying by a power of 10 does is truly, all it does, it moves the decimal point to the right. Okay? That's what it, by the same number of zeros you have in a number. That's what we did here too. Think about it. This is truly the number 7. 7.0. 1 0 moves it to the right 1. There's 70. This is truly 7.0. 2, 1, 2, because of 2 zeros gives you 700. So that's what a decimal really does. I couldn't say that in Mod 1. I just said add a 0. I couldn't say it because we didn't learn decimals yet. But truly, when you multiply by a power of 10, 10, 100, 1,000, 10,000, what you're doing, you're taking a decimal and moving it over to the right, the same number of decimal places you have in your power of 10. 1 place, 2 places, 3 places. That's what's really, really, really going on. Okay, one other thing I want to say, because I don't want you to get confused by this. When I was multiplying 0.7 times 100, and I put the 100 on the bottom, I want to do this 2 ways, just for a second, is I said it doesn't matter when you multiply by 0, you still get zeros. Well, if you're working on the bottom, you have to multiply all of these by everything up here. So you have to go 0 times 7, 0 times 7, 1 times 7. That's what I did. Okay? If I have this, okay, I have to multiply 0.1 times 7, 1 times 7, 1 times 0. I have to use all the digits down here by all the digits upstairs. So just because there were zeros here doesn't mean I wasn't going to multiply. Be careful about that. A lot of people see zeros and go, I'm not going to multiply by the 0. You have to, if you're down here, you're going to multiply everything down here by what's upstairs. Okay, you want to do that. So be very careful with that. So that's multiplying by powers of 10. Okay. Now, let's take a look at this next thing. Now, we just talked about multiplying by powers of 10 when the powers of 10 look like this. 10, 100, 1,000, 10,000, 100,000. Okay. What about when the powers of 10 look like this? 0.7 times 0.1. I'm taking the zeros out for a second just to show you something. Yeah, there are zeros there, but just to show you something. 0.7 times 0.1. Okay. So, there's one in one place here, in one place here, so it's got to be in 2 places here. 1 times 7 is 7. Where do I get my 2 places? Well, it's right here. 1, 2. 0.007 is my answer. So this is 0.07. Now let's look at 0.01. 0.01. .7 times 0.01. Okay, so again, 1 place here, 2 places here, 3 places here. 1 times, look, I'm going to multiply everything down here by everything up there. 1 times 7 is 7. 0 times 7 is 0. But I need 3 places, so I need to do this. 0.007. And finally, 0.7 times 0.001. Again, 1 times 7 is 7, 0 times 7 is 0, 0 times 7 is 0. 1 place here, 3 places here, 4 places here, going to have to add a 0. 1, 2, 3, 4 places. Okay, I'm going to write down the answer here. I'm going to take all this work off the board. I'm going to write down the answer here and see if you can come up with a pattern. And then let's talk about, finally, what's going on when multiplying by powers of 10. Okay, this is 0.0007. All right. Think about what happens to the decimal point. Okay? The answer here is 0.07. What did we do with this decimal point to get 0.07? Watch. We moved it over 1 place to the left. 1 place to left. Okay? Here, we have 0.7, but we want 0.007. How did we get that? Well, that moved 2 places to the left. And finally here, we have 0.7, but the answer is 0.0007. Okay, what happened here? Well, we started with 0.7, sorry. We started with 0.7. We'd have to go 1, 1, 1. So 3 places to the left. So 3 places to the left. So multiplying by a power of 10, like these, moves the decimal to the left. How do you know how many places? This was 1 place, this was 2 places, this was 3 places. Well, it's right here. 1, 2, 3 places, 1, 2 places, 1 place. So multiplying by a power of 10, like 0.1, 0.01, 0.001, actually moves the decimal to the left, okay, by how many places are in your decimal. Okay, so that's how you know. Okay, and that's quick and easy. If you don't want to use those little tricks, you don't have to. You could just plainly multiply. But watch how simple it makes the next problem. In 2007, there were 60.7 million married couples. And we want to write that in standard form. That means write the actual number. Okay? Well, that means 60.7 times 1 million. Well, now this is going to take us back to mod 1. Okay? Because let's do a million. Okay? This is 1,000. Right? This is 10,000. This is 100,000. A million looks like this. 1.000, not point, 1,000,000. That's a million. So we want to multiply 60.7 times a million. Well, that's a power of 10. It's a power of 10 where the decimal moves to the right as many zeros are in the number. So 1, 2, 3, 4, 5, 6. So we're going to move the decimal 6 places to the right. 1, 2, 3, 4, 5, 6. So we're going to have to add 5 zeros. So 6, 0, 7, 0, 0, 0, 0, 0. Put your commas in. 1, 2, 3, comma, 1, 2, 3, comma. Okay? So this is 60,700,000. So there are 60,700,000 couples that were married in the year 2007. And that's pretty easy, knowing that we can multiply by powers of 10. So that takes care of multiplying decimals. So we've done multiplying, we've done adding, we've done subtracting, but we wanted a little more practice with multiplying, show you what kind of applications we can use it in. So the next thing we're going to do is going to have a way to show us that.